Welcome to the absolute fastest way to learn data structures and algorithms with this premium revision material. Today, we are mastering LeetCode 101, the symmetric tree problem. Companies like Google, Amazon, and Microsoft love asking this to test your understanding of recursive tree traversals. Let us look at the problem statement. You are given the root of a binary tree, and your task is to determine if it is a mirror of itself, symmetric around its center. A tree is symmetric if its left and right subtrees are reflected images. This means empty trees are symmetric, and for others, we must verify that the values in structures follow a specific mirrored pattern. Think of this like the butterfly wing test. Imagine a butterfly with intricate patterns on its wings. For the butterfly to be beautiful and symmetric, every spot on the left wing must have an identical spot at the exact same relative position on the right wing. If you fold the wings together at the center, every single detail must overlap perfectly. This folding is exactly what we will do with our binary tree. For our strategy, we use a recursive mirror approach. The golden rule is simple: the roots must have equal values, the left child of the left node must match the right child of the right node, and the right child of the left node must match the left child of the right node. By checking these cross comparisons recursively, we can validate the entire tree. Let us dive into the dry run. Look at the tree on your screen. We have the root node 1 at the top. We start our algorithm by comparing its left and right subtrees. We define a helper function, isMirror, that takes two nodes, t1 and t2. First, we compare the direct children of the root. Notice the gold highlights on the two nodes with value 2. These nodes are equal, so our condition is satisfied for this level. But we are not done yet. Now we must check their children crosswise. Look at the outer nodes. Let us focus on node 3 on the far left, and node 3 on the far right. Our tracker highlights them, and since they are both 3, they match perfectly. Next, we look at the inner nodes. These are the nodes with value 4. Again, the gold boxes show that they are identical. Because every single cross comparison returned true, we can confidently say this tree is symmetric. Now, let us see how this translates into our Python code. We define a helper function, isMirror, which is the engine of our solution. First, we handle the base cases. If both t1 and t2 are null, we have reached the end of a branch symmetrically, so we return true. If only one of them is null, the symmetry is broken, and we return false. Finally, we check if their values are equal, and recursively call isMirror on the outer pairs and the inner pairs. Every call must return true for the entire tree to be symmetric. Looking at the complexity, the time complexity is O of n, where n is the number of nodes, because we visit every node exactly once. The space complexity is O of h, where h is the height of the tree, representing the maximum depth of the recursion stack. Congratulations on decoding the symmetric tree logic. Save this video for your next technical interview, and follow Leo Academy for more expert DS